welcome to your hands-on science lesson for the week. I have Holland here to be my super scientist apprentice. She is going to help me today, be my assistant, and we are going to do a great, fun, hands-on science experiment to build solar ovens today. Holland, do you have some questions about what we're going to do today?
Yes, I have 5 questions.
5 questions. Okay, make sure you speak up loud so our friends at home can hear you.
Okay, so what is a solar oven?
What is a solar oven? Okay, so I have a question for you. What is a oven?
An oven is something you put stuff like cookies, maybe pies even.
Okay, and what does the oven do to those cookies and pies?
It makes it hot.
It makes it hot, and it cooks it to where we can eat it, right? Because we don't eat raw cookies. No. Well, sometimes we eat raw cookies.
Sometimes we eat.
Yes. So we put it in the oven, and the oven makes it hot. So we are going to make a oven that gets hot, and it's going to get hot by the power of the sun. That's what the word solar means, is a sun. Sol means sun. And so we're going to make a solar oven that's going to be able to cook something, or at least get it hot to melt, and it's going to use the sun instead of being plugged in to electricity. Okay? What's your next question?
And my next question is, how are we going to get the sun because of all these trees outside?
Okay, how are we going to get the sun because of all the trees outside? It's definitely cooler right now on my back patio. I am filming this on Saturday. It's about 2 o'clock right now, and in the shade, it's very, very nice outside. So we're going to build outside in the shade, and then we're going to take our solar ovens to my front yard, which doesn't have any shade. And we're going to put our solar ovens there. So you do want to make sure that wherever you put your solar ovens to do this experiment, or your solar oven to do this, is in direct sunlight with no shade. Okay, so we're going to take these from the front yard to the backyard, but feel free to build inside if you're more comfortable with that.
Why are we putting black paper on the bottom?
Why are we putting black paper on the bottom? So hold it more over this way. Here you go. So you can see I have some black construction paper, and one of the steps that Holland's going to do to build is to attach this black paper to her the bottom of the pizza box. We're going to do that because the light and the heat from the sun loves the color black, and the black absorbs the heat better. In fact, my computer is black, and it's sitting here outside, and I felt that it was getting too hot, so I brought an umbrella out to shade my computer because my computer was getting really hot. So to help create the heat and trap the heat from the light energy of the sun, we are going to put some black paper in there to help it. Second grade has been learning this week about light, and that light is an energy. So just like we use electricity to power our oven, we're going to use the light energy to make the heat energy that third grade's learning about to cook our s'mores that we're going to cook. In the materials video, I'm going to mention, if you don't have s'mores, Mrs. Ellen suggested nachos. So if you have some chips and cheese, that will work for this experiment too. Okay, Holland, what's your next question? Speak up.
Why are we going to cover the s'mores with clear plastic?
Okay, so yeah, clear plastic wrap. So one of the materials is clear plastic wrap, and you put that over a certain part of the box for your s'mores. So there's 2 reasons that we're going to cover our pizza box or our solar oven with clear wrap. And one of those reasons is because what lives here outside that might love our s'mores? Bugs. She said bugs. Yes. Or creepy crawlies, as Mrs. Albert likes to call them. But all of my students know I love the creepy crawlies. But I don't love the creepy crawlies if they're creepy crawling on my s'mores that I want to eat. So the plastic wrap is going to help protect them from that. It's kind of windy today. I don't want any part of nature, sticks, leaves, dirt, and to blow on the s'mores if I want to eat them. So I'm going to make sure that they are covered up. The second reason that I'm putting clear wrap on there is because just like your oven door, I want to be able to see what's happening in my oven. And Holland, have you ever seen me cook something with the oven door open?
No, but when you open it to get it out or let it cool down.
Okay, so when I open the oven door to take something out, or if I want it to cool down. So do I want to keep opening our solar oven box over and over again to see what's happening?
No, so you should put the clear stuff on it.
Okay, I don't want to keep opening my box. So this plastic wrap is going to help kind of trap the heat inside, but give me a window to see through it, just like your oven door has a window. But every time you open that door, for every second your oven is open, it loses 10 degrees of heat. And so if I need to cook something at 350 degrees and I have to keep opening that door to look at the stuff inside my oven, I'm going to keep letting that heat out. And in my solar oven, I don't want to do that. So I'm putting a window in so that we can see what is going on, but it will help keep that heat trapped, just like the glass window in your oven door keeps the heat trapped. The plastic wrap will help keep the heat trapped as well, okay? So I am doing this on, like I said, Saturday afternoon at about 2 o'clock. It is, let's see, 1 degrees outside right now. It is getting a little bit hotter than the meteorologist predicted. The high earlier today was just 79, and now it's already 81. I would not recommend doing this on Tuesday if you're watching this video. Tuesday, it looks like there's going to be storms. But Wednesday, Thursday, and Friday, the forecast for right now later in the week is partly cloudy and then full sun on Thursday and Friday. The high on Thursday and Friday is 91 and 96. So your experiments on Thursday and Friday are probably going to go much faster than mine is going to go today when it's only 81 outside. So just be prepared if you're doing this on one of the hotter days this week that your timing is probably going to be quite a bit shorter than mine is going to be today for the actual cooking of the s'mores or the nachos. But I think that's it. We are going to get started. Oh, she still has one more question. Okay, what is your other question, Holly?
Why can't we do it inside?
Why can't we do this inside? Well, is the sun inside your house?
No, but you do have heat lamps and stuff.
Okay, so we have lamps and things like that. I could potentially do this with a heat lamp from Steve's Tank, but that light bulb is made to make heat. So that is a different kind of light bulb. I have lots of other kinds of light bulbs around my house, but those are made specifically to not use a lot of energy. And nowadays they are energy savers. And so they're not producing a lot of heat. I can't use just a regular light bulb in Steve's Tank to make it hot. They don't work like that. And so I need something that produces the heat and the light energy that makes heat to cook my oven. If I just make this solar oven and I put it under a lamp in my living room, do you think it's going to work? No, it's not going to work. So we need that heat energy that the sun provides for us to be able to heat something, because the light bulbs that are in our house nowadays are made to not use a lot of energy. So they're never going to produce the heat energy that we need. What if I put it by a window? It might work if you put it by a window and the sun is directly shining down through the glass and there's no shades or blinds or curtains in the way. It could definitely work through a window as long as you're getting that direct sunlight. And I'm going to put mine in the front yard. It could definitely work on a patio or an apartment patio. You're just going to have to time when the sun is on your patio or on that part of the apartment if y'all are in a apartment. But I think that's it. We're going to get started, and the next video you're going to watch is all about our materials, and then from there we're going to put it all together.